Yeah, thank you very much. Very happy to be here and talk about this paper, which has been in the making for a very long time by now. So I don't even remember how long we have been working on this, but it has been several years, and we have all been working quite intensely on this. And this week we have submitted this, so it will come out as a working paper in 1 or 2 weeks, I think. And then I will also share the link with you, so that you can read all the details, because we have so many results. I will not be able to cover everything today. I will just explain a little bit the basics and then our main results here. Yeah, as you can see, this is joint research with Wolfram Schlenker from Columbia University and the NBER, Meha Jain from the University of Michigan, Hao-Yu Wang from University of Texas, and then Robert Finger from ETH. And our main question here is, what's the causal effect of countries' institutions on their crop yields? And we do it at a global level. So we ask, how important are institutions, which we will define in a moment, how important are institutions for global crop yields? Okay, so I will start now with the background just very briefly. So as you all know, crop yields differ enormously globally. If you compare crop yields of different countries, it's really surprising almost how big the differences are. Even for countries that are relatively similar in environmental factors or neighboring countries, we see huge differences in crop yields. And there has been a recent paper by Adamopoulos and Restuccia who find that this is actually not much explained by environmental factors. So it's not just that potential yields are so different between countries, but the differences that we see in crop yield and also in different kinds of productivity, these differences are explained by socioeconomic variables. It's something about these countries that make the yield so different. It's not just the soil or the rainfall, even though we all know that soils and rainfall are important, but they are not the main explanation for what we're seeing globally. So we have a lot of proximate explanations, right? Like many agricultural economists have spent a lot of research over the past decades looking at a lot of proximate factors or more micro explanations, especially connected to technology. We see that technology explains really a lot of crop yields. Things like farmers who don't use the modern varieties, they don't use machinery, they don't use a lot of fertilizer, irrigation, all these things. These are the farmers with lower yields. And these are explained in turn by things like lacking insurance markets. It's really risky for many farmers to invest in technology. There are liquidity constraints that farmers simply do not have the money to do these investments. There is a lot of heterogeneity in terms of profitability. Very often, the direct explanation for non-adoption of technology is it's not profitable. For some reason, something else is missing. Maybe the road infrastructure is not good enough, trade deal, whatever it is, somehow the technologies that would increase the yield are not profitable. The more fundamental question is then, are all of these things maybe connected to institutions? Maybe the reason why the roads have a certain quality, or the reason why fertilizer is too expensive in a certain place, or insurance markets are lacking. All of these things could potentially be explained by something else more macro at the country level. And one of these pretty clear candidates for this are institutions. And there has been this extremely old literature on institutions, of course, starting with Adam Smith. So basically the starting of economics. From day one, people thought about institutions. How should society be organized so that people can be productive? And then, of course, Acemoglu and all these other very famous economists who have again and again shown how important institutions are for the economy at large. So it's not really a big question anymore whether institutions are important for an economy overall. It's pretty good evidence that institutions are important. It's just specifically for agriculture that we don't really have the same kind of empirical evidence. How important are countries' institutions for agriculture, and specifically here, agricultural crop yields? Institutions can be defined in many different ways. By the way, should people ask questions in the middle or at the end? What's better? Let's do it in the end then. Okay. So institutions can be defined in multiple ways. In general, as institutions, we understand the rules of the game. So how is society organized in economically relevant dimensions or in legally relevant dimensions? There are political institutions like, is the country a dictatorship or democracy, or what kind of government do you have? Economic institutions then comprise everything that affects how the economy is working. Starting from property rights to credit market regulations to taxation. All of these things are somehow organized at the country level, and they affect how people go about their businesses. And here we focus only on the economic institutions because we have an economic question. So you could think that the political institutions have an effect on the economic institution, and those affect our outcomes. But for us, the most relevant institutions are the economic institutions here. And what we rely on quite heavily here is we use the index of economic freedom by the Fraser Institute, which is a pretty well-established indicator summarizing a lot of individual sub-indicators. It's available for almost all countries, or for the majority of countries globally, for a very long time. So we have data for the year 2000 until 2019, and we have this indicator available for the same period. So we can really have the biggest data set possible here. And the Fraser Institute itself says that this is the most objective and accurate measure of economic freedom. So they directly connect good institutions to economic freedom. Their definition is the best institutions are those that provide the most freedom to people. So whenever there's something that somehow hinders people from being entrepreneurial or being productive, those are bad institutions. And you will see global maps in a moment where you can see exactly what kinds of countries have the best institutions by this definition and which are constraining their citizens more. It has been developed by a Nobel laureate, Milton Friedman. And two very good things about this indicator, besides its comprehensiveness, is that we can also look at all the individual subscores. So all the things that go into this indicator, we can also then look at separately in a moment. And it is on a 0 to 10 scale. 0 are the least free countries and 10 are the most free countries. So it's quite intuitively to interpret. We can say, okay, what happens if a country moves up one score, 1 point? For each point on the 0 to 10 scale, what happens to crop yields? I think it's easy to understand, relatively easy to understand what this means in terms of magnitudes. As I mentioned, this exists for every year here. I'm just showing the first and the last year of the data. So the left is for the year 2000 and the right is for the year 2019. And you can see the very free countries are the US or Switzerland or Australia is pretty free. So these are, Japan is pretty free. So basically the countries that we know are high income countries also tend to be pretty free. And in the literature, the logic is it goes from the institutions to the income mostly, that these countries are also so high income because they have such good institutions. And then you have countries that changed also quite a lot over time. That's very nice for our analysis. So you see the decline in Venezuela. Venezuela used to have pretty free institutions, and over the entire period, it got less and less free. And I think many of us know the story of Venezuela from the newspapers, how economic freedom and institutions declined and the economy declined with it. You also have the opposite. You have countries where institutions got better over time and economic growth was accompanied with this. So all of this is pretty much in line with institutions are good for the economy. So our question, how important are institutions for agriculture yields? What we first need to do is, first of all, we need to deal with differences in growing conditions. We do not want to compare countries that are pretty far away from each other, that have completely different agricultural conditions. So what we do is we estimate spatial discontinuities at country borders, where we say two countries share a common border, and how much do crop yields change when you cross the border. So here, close to the border, usually you have the pretty comparable amount of rainfall, similar soils, everything similar, pest pressure. And then what changes at the country border is the country's institutions, but also, of course, policies, maybe culture, other things. But we already get rid of these growing conditions that also are quite important for agriculture yields. So we use remotely sensed data for the entire globe. We started with data 100 kilometers away from the border. So we have 83 million pixels at a resolution of 1 square kilometer for every year. And then we use the maximum of the enhanced vegetation index as a proxy for yields. This is the best measure or proxy measure for yields globally to get relative yields. Has been verified a lot in studies where this measure has been compared to alternatives. Especially, it's important to use the maximum, not the mean, because the maximum really measures what's the highest yield in the year. So we get really the crop yield. If we would use the mean, this would be biased by everything else that's on the field that's also green. So you can imagine sometimes a field has no crops and it's still green because something else grows there, or there are bushes around it that are somehow captured, or there's some grass growing. So all of this is captured in the mean, but none of this is usually the maximum on the crop yield. So if we have only cropland pixels and then we use the maximum of the vegetation, that's usually the highest yielding crop, which will be wheat or corn or a plant like that. So we estimate for all the country pairs that we have globally, we estimate these discontinuities per border and per year. So we have a lot of discontinuities to start with. And then we link these discontinuities to the Fraser index, where we have a panel model that is a little bit like a difference in differences model, but it is a differences in discontinuities. So it has the same logic like differences in differences, but we focus on discontinuities, which helps us to have the parallel trends assumption, for example, be valid, much more likely, as we can also show. And in general, we first get rid of the growing condition differences and then have all the fixed effects and so on from the difference in differences model, as always. It's also explained in our review paper from this year. What we have played around with quite a lot in this paper is how many legs do we need? So the important thing is institutions are unlikely to directly just have the maximum effect on yields and then it's done, but much more likely you improve institutions and then over time they have an effect on crop yields, because at the least the farmers need to have taken into account that something has changed, then changed something on the field, and then it still takes a year or something before you can see plausibly an effect. So we have played around a lot with different kinds of leg structures, and what we find is that after a certain amount, I will show that in a moment, after a certain amount, the effect stabilizes after about 5 years. And what you see then, if you take the average of the institutional quality from the last 5 years, that for each 1 point in the index, yields increase by 2.2%. So for each improvement, you get 2.2% more crop yield, which is, I would say, a medium effect. It's smaller than the institutional effect on the entire economy, which makes sense because crop yields are not only under the control of humans, but they're still affected by other things like the weather or pest pressures. But it's big enough that I care about it. It's not something where I would say, oh, I don't care if we can increase crop yields by 10%. If we can do that, I think it's a pretty big deal. So yeah, I would say this is a medium effect, as I mentioned. Unfortunately, we also do find some evidence that there's also an extensive margin effect, meaning that it's not as clear as our other results, but it does seem that better institutions also lead to an expansion in crop yields at the expense of forests. So the higher yields are an incentive to the farmers to then deforest and have more crop fields if now they can have higher yields and arguably then also higher income because of that. And then we do decompose the overall institutional index also into all its subscores, because we were really interested in which institutional dimensions actually matter. If we have such an encompassing measure of institutions, what is really driving the effect? And it's really macro what we are finding. We are all having a background that's much more micro, but what we are finding is inflation control, credit market regulation, and top marginal tax rate are the important institutional characteristics that are so important here. And these three together basically explain our institutional effect. So this is really consistent, I think, with World Bank and these big organizations' logic for a very long time, that you need to get these macro things right to get the economy going. And for some of these, I think there's very little other research available in agricultural economics. I'm not aware of a lot of research on the effect of inflation on crop yields or these other things. So these things are clearly things that farmers and business people are complaining a lot if you talk to them, but it's not really something where this huge other literature exists for, I think. Just as a motivation, I always like to show these kinds of pictures because these are the starting point of our analysis, where I mentioned that you have countries where growing conditions are quite similar and then the crop fields look differently. This is a really obvious example at the Turkey-Syria border, where one side is heavily irrigated and really intensively farmed, and the other side, first it looks like there is no cropland, and then you zoom in and you do see the crop fields here. They're just not looking as intensively farmed and not as productive as the other side. And that's exactly the foundation for our econometric approach of quantifying these discontinuities. And just to show you how this then looks in our data, so here in this figure, we have on the x-axis the distance to the border, and then on the y-axis you have the log of the EVI, so our yield measure, and in the middle there's the border. And basically our data here directly replicate what you have just seen. You have Turkey on one side, Syria on the other side. Then we have local averages of the crop yields on the Turkey side, where you see there's some fluctuation, but it's not too far. And then you have the same fluctuation all on the Syrian side, but the level is quite different, right? So if you put in regression lines here, you see that these two countries right at the border have pretty different levels of crop yields. And then you get this discontinuity right at the border, and nothing else changes at this border. It's just the country border. It's not that rainfall jumps or soils jump. It's really just one side is farming more intensively than the other side. Okay, so I think most of this I already mentioned. What we do is, as a start, that we try to quantify these discontinuities. What we're doing here is we have a global data set that first of all categorizes all the pixels that we have into different land use classes. And we have two land cover classes that are cropland. One is more than 60% cropland, and the other is more mixed cropland with something else. So in the US, for example, you have mostly the first category, where a pixel is usually covered by homogeneous cropland, and then in most developing countries, you have more the other category, where you have more smaller fields and then some trees or something else, natural vegetation in between. And we take into account with that we have this with fixed effects, because of course these two classes might have different greenness just because of the structure. Yeah, we have 83 million pixels for our intensive margin analysis, and then for the extensive margin, where we look at all the land cover classes, we have more than 350 million pixels. So we really have a lot of data. We don't have to worry about statistical power here. And we run separate equations for each year. And then we have border segment fixed effects that I will show in a moment what these are for. And we have land cover fixed effects. And we also always control for longitude and latitude and a cross term just to get things out that vary spatially continuously. So if rainfall decreases going from north to south, or temperature increases from north to south, these are completely controlled away then by the latitude variable. And as robustness checks, we include a lot of control variables, but these control variables are really just a robustness check. They're not there to actually control for these things. We're not saying these are confounders and we need to control for them. It's more a check. If our results would change a lot by including them, that would more be a warning signal that we have to change something else. And based on the literature, for most of these environmental variables, we use a quadratic term, and then we also control for soil class. We vary the maximum border distance just to see how robust are our findings to the chosen bandwidth. We also estimate what's the statistical optimal bandwidth, that's 25 kilometers. But this is a little bit sensitive to a lot of choices that we make. So we prefer to show that actually a little bit smaller or a little bit larger doesn't really change our results. And we have one more requirement, and that is we want to have at least 100 pixels on each side of a border to include a border. This is important because not all borders around the world have cropland. Or a lot of cropland on each side. So if you look at the border between, let's say, Colombia and Brazil, that's in the middle of the Amazon. There's not a lot of cropland. So whatever we estimate there is not reliable. That might be a huge outlier if we have 2 fields here and 10 fields here, and they're even further apart because nothing is really close to the border. So we exclude all these borders that are not really providing us with good data. Our data comes from the MODIS satellite, and this is a really big criterion for us. We want a global unified measurement of crop yields. We don't want to rely on anything that's affected by country statistics, because differences in reporting could then also explain differences in yields. I mean, if different countries have different ways of measuring their crop yields or reporting their crop yields, that would not really be reliable for us. For our global analysis, we want to have a completely unified measurement, the same satellite orbiting the Earth, measuring everything the same way everywhere, and then we can compare. It has been verified a lot that the EVI works well in capturing relative crop yields. It has multiple limitations, but the biggest limitation is because we focus on the maximum, we only get the highest crop per year. So if better institutions have an effect that people have multiple harvests or one more harvest per year, we don't capture that. Or if only the second highest harvest increases, we don't capture that. We only capture the effect on the highest yield per year. Because I mentioned these segments, here I go back to our example of Turkey and Syria from the beginning. Here you see it's nice. You have a lot of cropland on each side. So this is a border that works very well here. You could also see that on the picture before. The one thing is, at some borders, you might not have cropland everywhere. And we want to avoid that we then compare cropland from one side that's all the way to the one side to cropland that's all the way to the other side. So what we do is we have these border segments that we say we only compare pixels that are really on opposite sides of the same border and arguably share a lot of common conditions like similar rainfall and so on. And we see that this makes a difference. It doesn't really change our results, But if we plot our data, we see that the data looks better when we have these included. And then here, because you probably now wonder what borders are even left, these are all the cropland pixels globally at all the borders. You see Australia, unfortunately, has no direct land borders, so Madagascar, Australia, and so on, we cannot really have. And then we are left with the blue borders. So the red borders we exclude. Is that right? No, it's the opposite. Wait. Which borders do we? Yeah, the blue borders we have left. So everything else either is lacking enough cropland close to borders, or sometimes in some years, there's also the institutional variables are not available. So we have borders from all around the world, 83 million pixels from all continents. It's all good. It's just that some individual specific borders we cannot include here. Okay, and then the big part, how to link this to discontinuities in institutional quality. This is the big thing. Many things change between countries. You cannot say you go from Turkey to Syria, the only thing that changes are the institutions, everything else is exactly the same. Of course not. So sometimes even natural factors abruptly change. There are borders in our data where even at the border, the environment does change. Not in the example Turkey-Syria, I believe, but I think there's a border China and Bhutan, where Bhutan is considerably higher, and then a lot of things change because of the topography. The rainfall changes, solar radiation changes, the soil changes. Basically there, you cannot control for all these differences then. The other thing is our institutions might be quite correlated with things like culture. So countries have different cultures, and for that reason, probably also in part different institutions. And we don't have measures of culture in here. So our work around here is to focus on changes. So we say, when institutions changed in the past, what happened to the discontinuities in the crop yields? Arguably, geography and environment stays constant. That doesn't change. So that should be absorbed by a border fixed effect. And things like culture arguably just change slower than the institutions. So institution is something you can change quite quickly. You just change the law. You just introduce new things to fight corruption. You have a deregulation of a sector. These things are quick. Changing culture takes time. It's a slow process. So that will follow, but by focusing here on these direct changes, we think we can identify the causal effect on the culture itself. Yeah, as I mentioned, we still have the parallel trends assumption from differences in differences, and we tested by including leads. So if we find that only the lags are significant and the leads are not, that's a pretty good indication that we can identify the causal effect in the setting here, and we find that this is the case. One more thing is we were also wondering whether a linear model is really appropriate here, because you could have a lot of deviations from this linear setting. For example, you could think that institutional improvements are only important for countries with relatively bad institutions. And once you cross a certain threshold, it doesn't matter anymore. So does it really matter that Switzerland has better institutions than Germany? Does that have any effect on yields anymore? Or do we say, okay, once you have reached that level, it doesn't matter? Or the opposite. Does it really help if a country with the worst institutions improves a little bit? Does that already provide any incentive for farmers to adopt irrigation or whatever? Or do you have to reach a medium institutional quality first before farmers at all respond to this. So we could imagine various deviations from a linear relationship here. So we use a restricted cubic spine model here. And what we're finding is that if we just include one leg, we have this shape that does not look linear. What this implies is, if you look at this, you have the institutional quality on the x-axis and then the discontinuities in yields on the y-axis. It seems like the response is much bigger in countries that had already better institutions. So this is in line with, if you have really bad institutions, a little bit of an improvement only helps a little bit, but not really a lot. So it seems like you should have better institutions to really benefit from this. However, the more legs we include, the more linear the relationship gets. So this tells us a different story, actually. This means the response in crop yield is only faster in countries with better institutions, and you just need to wait a little bit longer in other countries. So basically, after 5 years, it doesn't matter anymore. It is just that better institutions mean a faster response, and after 5 years, better institutions are better for all countries across the board. So whether you have really good institutions and you still improve them, or you had really bad institutions and you improve them, for all the countries in the world, on average, it seems like institutions matter. Yeah, so we find a delayed effect. The nonlinear effect is only there in the beginning, but not later. So what we can do from here on is we include 5 legs and we use a linear model. Okay, and then these are our first results. I'm always showing here the different bandwidth starting from 15 kilometers up to 50. In the paper, then in the appendix, we also show 75 and 100, but this is, it's a little bit too much because then we are already so far away from the border. It's not really anymore that we can say similar growing conditions. And as I mentioned before, 25 is the optimum. So what we find is, no matter which bandwidth we look at, it's always significant. If we are really close to the border, then it's only significant at the 10% level, but basically in the optimal bandwidth, it's highly significant. You can see it's always a very large number of pixels, even higher number of, or a very high number of observations and a lot of borders globally. And this is the main result that I already mentioned at the beginning, 2.2% increase for each point on the institutional indicator. Then something that that we did as our first robustness check basically is we compared what happens in the sample of countries where the better side switches. There are 39. There are 39 cases where in some years one country had better institutions and in another year the other side got better institutions. Because there is so much variation both between and within borders, we have all these cases where things switch. We also have 96 cases where one side always had better institutions. I mentioned Switzerland, Germany. For our entire period, Switzerland had better institutions than Germany. This never changed. So this would be a border that's included here. And then we can also have, again, the full sample. And the interesting thing is, whether we look at the borders where the better side switched at some point, or we look at borders where it stayed the same every time, it's basically the same effect that we find in the full sample. So the result is incredibly robust. And we find this in multiple ways that our result is so robust. And you can think that this rules out a lot of potential concerns if we find that the switchers look or give very similar result. Yeah, so we have looked at the level of yields or how high is the maximum level. However, for farmers, it's also quite important how variable those yields are. Farmers care about risk. So increasing the level of yield, but then having huge standard deviations is not very attractive to all farmers. If farmers are risk averse, they also have a preference to have stable yields in addition to having high yields. So we look at deviations from the mean. So we have standard deviations for the period 2000 to 2003, 2004 to 2007, 2008 to 2011, 2012 to 2015, and 2016 to 2019. So just the average standard deviation. And we find absolutely zero effect of institutional changes on variability of risk. So this is really interesting. It means better institutions lead to higher yields and they have no effect on the variability, meaning that, and it's even a negative sign. So if at all, we would even say it's risk reducing, but it's not significant at all. So it's not that the farmers are taking more risk. They're not switching to varieties, for example, that are super sensitive or anything. They're doing something else that's just increasing yields. And I will show you in a moment what we have for evidence, what they're actually doing differently. Yeah, for the environment, people also care a lot about possible side effects. You increase the yields of the farmers without increasing their risk. They have an incentive now to expand their cropland. So we look at all the pixels that we have close to borders, and we say, how likely is it that a pixel now changes after institutions improved from a forest pixel to a cropland pixel or something else? I can skip over the technical details, how we do it exactly. And what we find is always a positive coefficient. You can see in the smallest bandwidth, it's not significant at all. In the optimal bandwidth, it's also not significant yet. A little bit higher, it gets significant. So this is not bulletproof evidence that there is clearly a move to cropland, but it's nevertheless worrying. It still is an indication that at least at some borders, or there is a trend towards farmers expanding their cropland. And you also have to imagine we have a little bit more measurement error in these classification and our other measure, because globally the EVI is incredibly well measured. It's really exact, really high resolution. These classifications of is this actually cropland or something else, especially in developing countries, especially if you look at small scale farming where fields can look quite natural sometimes. Sometimes it's really difficult to say, is this savanna or is this a crop field? It's not like in Germany where it's so clear what's natural, what's not natural. It's much more mixed. So with the measurement error and everything else, and possibly a lot of heterogeneity around the world, finding significant effects in just slightly larger bandwidth is at least a signal that we should pay attention to this. And even more worrying, if then we look at the forest pixels, it's exactly the opposite, always negative. And in the smaller bandwidth now, it's almost significant. So again, it's not as clear and robust and bulletproof as our first results, but it is worrying. So if you care about the environment, at least this is something where you say, this doesn't look great if you have always an increase in cropland and then always a decrease in forest pixels. Okay, I have to hurry up. Yeah, here we look at all these different sub-scores. First of all, we can do this in groups. That is already how it comes. The index comes in 5 different categories. And what we're doing here is we look at the categories individually and then throwing them all in the same regression. And something that's that comes out of here is that what's always significant is regulation and money. So all the financial macro dimensions. And then if we look at them even more disaggregated, really to the smallest level, we find that these 4, and especially if you look at this, is not really significant, but these are top marginal tax rate, inflation, and credit market regulation, that these together perfectly explain our overall finding. They are, of course, not completely independent. So they are, you cannot exactly interpret each coefficient, but these are the ones that are robustly throughout, robustly coming back. And now I just want to move very quickly because I don't have much time. I just wanted to show very quickly what we think is driving these results. So first thing is we look at evapotranspiration just above the crop fields, because if we think it's irrigation, very little irrigation is perfectly efficient. So usually irrigation should increase measured evapotranspiration across the fields. And you can see it's, no matter what we do, really statistically significant. And the coefficients are even larger than the crop yield estimates. And that is because about half of this increase in evapotranspiration simply comes from higher yields. So if you increase yields, automatically you get some more evapotranspiration. But because these are so large, about half of this is because of irrigation. So we find really strong evidence that a major driving force of this is irrigation. And then the other is we look at what's the exact day in the year when the peak of the yield is achieved. And this is an indicator for mechanization. Of course, globally, we don't have data for exact mechanization, but one thing that mechanization allows you is to plant a little bit earlier, and then you can harvest a little bit earlier. So you're just faster in what you're doing. So you would expect that if people mechanize, that the maximum yield occurs a little bit earlier. And what we're finding is that, yes, in our data, these increases in institutions lead to maximum harvest or maximum yield that is about 1 to 2 days earlier. So we do find evidence both for irrigation and mechanization. Yeah, I think I can skip over the summary because you just heard these things. Just to wrap it up, we have, as you all know, this challenge of food security ahead because we have growing demand. We need to supply it somehow. In many regions around the world, yields are not increasing as fast as we need them to. Global warming will have the opposite effect. Global warming in many countries will decrease yields. In some places, this is going to be a really strong effect that we first need to compensate for because we can talk about increasing yields. And what we find is that institutional reforms do seem to be a good policy lever here. And the important thing is, because we find this evidence that increasing crop yields might lead to cropland expansion, we think it's important to accompany these institutional improvements then with conservation policies to make sure that the farmers are free to be as productive as they can be, but then they're constrained in that they can externalize environmental costs. Thank you very much.